Gut. Let's take this for example. You find your backpack? No. What the heck, man? So everything in it as well?
Huh? No. Only the Spanish textbook. I still don't have stuff. Oh wait, actually, not my math, like all my old stuff.
Wicked. You think somebody's playing a practical joke on you, or you think you left it at home?
Honestly, kind of.
You think you left it at home?
All my stuff got like put out on my desk, and my backpack and computer charger were gone. Wow.
So it's not at home.
No, it's definitely not because I had it for 2 days.
Flip flop over there.
Yeah.
You're one of those likes of beach chicks.
Yeah.
There's a couple of them there. Tristan's one of those guys. He's always. Oh!
Either of you like to aid me in the process?
No.
Yeah.
Oh,
No, I had to bundle up.
Like once a week you come by for half
I'm
hour.
cold.
Oh god,
I
I'm
just
gonna be a part of
do
something
not
with
care.
Food.
Maybe.
Okay.
I'm sick of me to leave Midland and say hi to everyone for the rest of the year.
You're not gonna leave Midland. You're gonna be dead underneath once the buildings collapse on you. Digging under your cabin's one thing, but digging under a hill that can collapse. Like
That's just stupid.
Have you been in Sophomore Cave? Sophomore Cave is made of the same content as Varsity Hill.
with sophomore cave.
It's
like-
just a cave.
No, it's like a 20-foot long tunnel in the side of the
It's
hill.
a cave.
Have you been to it?
No, I know what it looks like though, because Gael showed a video.
Well, Gael didn't even find our one. Gael found like 2 prolonged sophomore caves.
Wait, where is it?
I don't know what those the real one is, but the 2 false sophomore caves are just like 20-foot long tunnels. People know.
Wait, have you seen them?
Yeah, I will. Oh, I'll run to one with the parents.
Wait. Is it in the river?
No, it's in the canyon. I'm gonna dig this up yard. And just so I can't figure it out. It's a big pack.
Dig it from somewhere else.
No, that's from like 3 or 4 minutes walk up from the base house. Like right.
Good morning.
Brett, that's gonna take
So
so
in a
long.
second, will you
So
go
I
ahead?
think
That's
half
gonna
the
take.
time you know.
But that's gonna take your
Maybe I
entire
need some
time.
scratch paper for the warm up.
Oh, not if you just
Scratch paper?
You're the one. You can make this all happen.
Okay, so. You have any scratch paper? We're gonna do a quick, there's a little warm up on the board. I like
Brett,
that.
that is gonna collapse so fast.
No, it's not.
If you make a tunnel like 20 feet long, it'll collapse. No, make one this size.
That's
It's not
what it
collapse.
is.
Unless you
So far,
fortify
it's
it
like a
some
king
kind of
now.
way.
You have to get so
No,
much.
no, sophomore year was like a 20, 30 foot long.
Think that.
No, it is not. Yeah, this place guy else.
I figured out into solutions. Everyone
Yeah.
You.
Wait.
You are wise.
Sweet.
Alright, everybody, check out the agenda on the board. And then, smack dab in the middle of the board are 4 little warm-up problems. Back off the major findings, algebraic skills, so, you got about 5 minutes to do those? Okay, you ready to rock? So, everybody, I want to go ahead and jot down that first one. Alright. I just want to go over the idea of what's simplified. Here's the first one. Just jot down A, 45 63 times 3/5. should always try to simplify, even if there's no command. Our job, you can walk around saying I'm 10 plus 5 years old, or 10 plus 1 times 5 years old. Generally, you say 15. So if you see anything like this, you wanna
It's Joe Madison's birthday.
boost.
Joe Madison's.
Oh, really? Where's he? He's about my age. So, anybody just wanna walk us through how they would simplify? By the way, there's often more than a couple ways to simplify. Often, not always. Anybody just wanna talk about how they would simplify this right here? Multiply straight across. So, okay, 45. So I'm gonna do this and then I'll probably erase and I'm gonna ask the problem again. So if you're like, I do it different, just hang tight. Multiply straight across. That's not breaking any rules. 45 times 3 is 135. 63 times 5. I know what 5 times 60 is, do you?
315.
Yeah. 315. And then what would we have to do, Warren?
Simplify.
How would you do that now?
Divide by common factor.
Okay, what's the common factor of 135 and 315?
5.
How many times is 5 going to 135?
A couple.
Yeah, a couple few. And this is, I mean, if you gotta show your algebraic sets, it's okay to let it use a calculator to help you out. I mean, if you wanna do that. I know 5 goes into 100 20 times. How many times is 5 going to 35? 7. So this should be 27. How many times is 5 going into 315 or? So this become your problem.
63.
63. Okay, so then we would do this, right? Okay, are we simplified yet?
3.
Take out a 3. How many times is 3 going to 27?
9.
Sorry, 9. 9 times. And then 3 goes into 63 21 times?
Yeah.
Okay. There's more.
You can take
Let's
away
look.
3 out. So
You take 3 out of
3 and
9
7.
and 3 and 7. Okay. So in the end, it simplifies to 3 sevens. This is all legit. This is all great. This is all logical. It works. And the answer is 3 sevens. By the way, if you put this into your blue and white calculator, it should spit out 3 sevens right away. Which is cool. You should know, but you should know the steps that get there. And this is one technique, and there's nothing wrong with it. All right. I'm gonna erase this in 10 seconds, and I'm gonna call on Odin and see what he says. Okay. And then I'll Shamsu, you can talk to that. All right. And 5, 4. All right. Another way to simplify this. Odin.
Okay, 45. If you divide 45 and 63 have a common factor, which is 9.
5 times 9 and 6 times 9, right?
Exactly. So you can just turn it into 65,
Five,
or it would actually be 7 times 9.
Oh gosh, yeah, thank you.
So it'd be 5 over 7 times 3 over 5, which would be 3 over 7. 3 over 7.
Oh, do you see how he's just jumping to 3 sevens right there without having to like multiply straight across? This is totally legal. If that is a multiplication symbol, then I hope you can kind of follow through why that would work. So we get 3 sevens a little bit quicker. All right. Anybody have a Shamsu? Well, actually, let me. I think it's worth jotting these different paths down. It's literally the breadcrumbs that lead you to a solution. None of them are all. They all get you to the same place. All right. Shamsu, you're on.
Well, this is just always how we do it, is cross out the 5 and then change the 45 to a 9.
Okay, pause. Do you see what he's thinking? He justified his step. It's really great. It saves time and space, and it's totally legal. Bryce, can you see why that's the true thing or an okay thing to do?
Yeah, so you would just cross out the 3, make it 63 or 21. You got have a 21, that's 3 over 7, a lot quicker.
Okay, so you're saying you can use the same technique that Shamsu did to simplify that. So you kind of see the reason. Can somebody just explain Shamsu's stuff right there?
You divided both of them by 5.
Alright. I guess, yeah, 45 fifths is 9, isn't it? 45 fifths. Could we do that if this was a plus symbol?
No.
Okay, let's just be real clear, that's a different kind of situation. Since it's multiplied. Okay, Shamsu, you're on.
And then cross out the 9 and change the 63 to a 7.
Alright, so I don't even have to like rewrite the next thing. You're saying I can just kind of work up in here for a second.
Yeah.
Okay, great.
Keep
So 9/63 is 1/7. Agreed? Holy 3/7. Okay.
What's the 17?
Alright. I chose these problems just because they involve some simplification. And I wanted you to practice it, make sure you were getting to the simplest answer. And we just saw 3 techniques that all did the same thing. Some are quicker than others, they're all legit. We do B, C, and D, and we'll give about 5 minutes. Simplify them logically. It's okay if you do work up on one line. If you see it and it makes sense, go ahead. I'm not gonna make you write every single step out. Because I know you've done this before. So, you've got 5 minutes. If you have any questions, let me know. Yeah.
In problem B, what does the 17 refer to? Looking blank for
Oh.
the radius.
17 is the radius in this case.
Okay, do we know what the degree of the angle is?
Oh, I meant to write, yes, thank you. I meant to write 60. Let's see. I think it's in
We should just have one in each
Push
corner.
it, how small fan it is, does this.
Just have one in each corner.
They make,
Like,
stove top fans that are basically just like, they're not
they're like
plugged in or
induction
anything.
or,
Yeah.
what's the word?
Induction.
Yeah.
Induction, yeah.
We have one of those at my house.
The one in the library.
Well, what if you just had the chimney go in like a circle and then go up? 'Cause the chimney would radiate heat, right? So the giant stove pipes around the room.
I think we should just circulate warm water around in pipes like steam.
You know, sharp alternatively,
Just a lot.
10
Yeah.
spacers.
if you let me dig a basement under this, I'll put a shower fire in it so you can have the warm water.
Bryce, why are you obsessed?
What is with you in basements?
Bryce, I want you to know that I was part of a team that hand dug a basement in Portland once. It was like 20 by 20 by like 10. It took a solid week. We couldn't get any heavy equipment into the backyard, and these homeowners really wanted to have a daylight basement. So it's like they had a two-story house that sat up on a perch, and they wanted to get light into the basement. So it's called a daylight basement, basically just lower the ground level. So we had all kinds of crazy contraptions to get like the dirt up before you'd have to like wheel up these 2x12s. It was,
How many laps did you get?
I don't know yet, but I have a quick question. Could you help me out with something?
if it's math related right now, yeah.
No, not basement related.
Not right now. How about during the break?
During the break.
Yeah.
I gotta talk to you.
Bryce. The point where you gotta drop it.
Yeah.
Okay,
You
what
just
about
basically look for fluids. Sometimes you can do sort of like trial and error. There's a one go in each of them, of course. Well, the two go in each of them. Yeah, they're both even. That's probably pretty small. One clue, at the end of 0, you know, at least 10 goes into it, right? So that'd be a quick one to take out. Shoot for the biggest. Have you ever seen somebody just cross out the zeros at the ends?
Yeah.
Do that, so you don't have to rewrite it. Cross out those 2 zeros. So really another question is, 58, 310, and you might be like, well, I know 2 goes in each of them, right? So with using just in your head almost, you'd be like, I know it's 27 over, let's see, 400.
45 divided by 360.
Go ahead and do the numerator first.
Oh, yeah.
405 and pi. So then, like, now, like, don't worry about what goes in there, just say, I wonder what goes into 27, I know it's 3 and 9, that's it, right? So maybe a question would be, you could check what the calculator is 405 divisible by 3 or 9? That's great, so take a 9 out of each. Ooh. 3 goes into 45 too. How many times is 3 over 45 and then you do that?
I think that's correct.
You got 5 fourths pi for C. Hey, for C, what are the going answers right now? 5, 6 pi. Anything else for C?
5, 6 pi.
We got a 5 fourths, 5, 6. We're close. We'll definitely go over it. Let's see. Anybody else want to offer up C?
I don't know, I got that. Circle, but I don't know how to get it.
You don't know how to get it.
Wait.
Oh, so hey, just remember the big idea is you find the fraction of the whole, right?
Yeah.
So 25 3/60. You find something?
I don't know, I was wondering, I didn't have this. I don't know.
Fraction of the whole. So
Wait,
oh,
hold on.
5, 6. So it's the same. It's the same formula, but instead of finding the distance, you find the area. So replace that with the area formula. So pi r squared times m over 360. Does that make sense?
You simplify
The
it.
fraction
I
of
was
the
just
whole.
thinking pi.
I got 5.625.
5.625 approximate.
Yeah.
So that's
no,
after-
5.625 pi.
Ooh, that's
Wait,
different.
5.65 pi?
Uh-huh.
Okay, I got 1.25 pi, which is about 5.
Yeah. Let's go. Let's knock out C together right now. Okay. Oh, actually, can we agree on B? What did you get for B class? 115. You should see this cancels out right away. Or now do you see that cancels out right away?
Yes.
And then you just need to reduce 24 3/60. And yeah, 24 goes into 360 15 times. Okay, arc length formula. Remember, we derived it or figured it out last class. It's just the length of a portion of a circle would just be a fraction of the whole. So we say that's the whole circumference. We're just trying to find this
I
little
didn't
piece.
find the length. I was doing the area.
Ah, there we go. So this should be, well, here, I'll start with the general formula. M over 360. M, it doesn't matter if it's X or M. This text decided to use M for measure. So the arc length, I'll say AB is equal to that. So plug in your radius, plug in your central angle, and then it's just a matter of reducing and simplifying. Anybody see a step that makes sense to them as far as simplifying goes?
1.25.
What could we put together or cross out or simplify?
2 times 9 is the same as 18 pi.
This is a good step. This is 18 times pi
And then
times 25 3/60. Remember how Shansu kind of reached across? See, if all these are being multiplied, you see that 18 is in the numerator and 360 is in the denominator. How would those affect each other?
well,
How many times does 18 go into 360? Yeah. That should reduce to. Now, does the 20 live in the numerator or the denominator? Here's my question. What is 18 3/60? Is it 20 or 120?
120.
120. So when we do this writing, we make sure the 20 is down below.
So you have
So we
pi
really
times
have-
25 over 20.
We really have pi times 25 over 20, which is 5/4.
Wait, did you
I have a question.
for me?
If it asks,
Go ahead, yeah. Go ahead.
Did you get?
if it asks for a length in inches, can you give it like in 5/4 pi inches, or do you have to simplify 4 pi? Like, do you have
Oh,
to-
good question. Exact is always good to go with, and then you could always approximate it.
Wait, for
You are not avoiding the questions by reporting it like this.
okay.
You are not avoiding the question. You're answering it very exactly without rounding, so this is great. Any questions about that technique? Just, you could do 18 times 25 over 360 and then simplify that. You would still get to the same conclusion.
Because
Anybody got an answer for D? You don't have to offer it up. You got one? Who else has an answer for D? Maddox? Anybody else? You got 3? You guys want to say it out loud on the count of 3 and see if we agree?
Sure.
It's nice to know if we agree. I mean, we'll do it anyway. We'll do it anyway. On the count of 3, you guys say it. 1, 2, 3.
5 2/3.
5 2/3. 5 2/3 what? Pi?
Pi, yeah.
What did you say, Odin?
48 and .168.
That's different than yours. 5 2/3 is different. Max, yours the same as any of those? Well, what is it? Is it close? What is it?
289 over 6 pi.
Yeah,
Okay.
that's the same
Yeah.
as mine.
Oh, 286 ninths? Or 2, okay.
Yeah, I just divided it.
And what did you come up with?
So I pretty much got the opposite of Owen because we're not calculating for this tiny bit. We're calculating for the majority of it.
Majority.
Oh, So you
Does that make
calculate.
So
You
you
find
put 289
that-
divided by 50.
Cool.
Well,
I have 150.
So you
So
can find.
like 240.83 repeating.
What is this?
Pi.
What is this angle right here? Then?
Oh, yeah.
What is that angle? that I just had?
390 degrees. Never mind.
300 degrees. Never mind. Well, let's whip it together then. Great observation. This would be sector area. Actually, I like to do it. SA sometimes looks like surface area, so I like to write area
You get
of a
240
little cone. And it's the area of a circle, so we change this. This is the only thing that changes when we start talking about area of a sector.
Yeah.
You change it to pi r squared. That's the whole. We times it by the portion. This is pi r pi 17. Who's got 17 squared off the top of their head?
289.
Thank you.
It's not off the top of my head. I just did it.
I have to think about it every time. So it's 289 pi times 300 over 360.
Which would equal about 240.8.
Yeah, how do you want to reduce this, class?
2 pi. Wouldn't that just be 5/6?
Yeah, maybe at this step, I could just recognize it,
Or
what you did.
5 divided by 6.
Yeah. Do any factors of 6 go into 289? Does 2, 3, or 6 go into 289? I don't know. I don't think so. 2 definitely not. So could 6 do it? If 2 can't go into 289, could 6?
no.
No, so does 3. That's
No.
so this is not going to that any no factors? So then I guess we just want to multiply straight across and call it good. So whatever 289 times 5 is, 240.
240.8.
No, it wouldn't be times
pi
by.
repeating.
What's 289 times
Oh,
5?
different.
We want to go exact first. Always go the exact right. So multiply this number to 5, put it over 6, and then put the pi out there. So what's 289 times 5?
1,445.
1,445. This would be the very exact answer. And this is in feet squared. And then you could always approximate it.
Right, I just got 240 and 5/6 pi inches.
It's 240.83 repeating.
Which would be 5/6.
So you turn it into a mixed number. That's fine. Or maybe I forget. Is that a proper fraction? Yeah, a mixed
It
number.
shouldn't be 5/6.
0.8 or 8.3 feet.
Oh, that bit, yeah. 240 and 5/6.
Okay. So the reason why I showed this to you is just to go over this idea of factors and the idea of simplifying expressions that have fractions in it. Both of these formulas that you kind of discovered last class involve a portion or a fraction of the circle. You can have the next 20 minutes to work on this assignment. Fine. Remember, anybody in this class is a resource. So I am your elbow partner. You can walk across the class and talk to somebody on the other side. Just say, hey, what did you do? What did you get? That is totally allowed and encouraged.
Can you look outside?
If you want. Sure. Alright, I mean, I think it would be better for all these ideas just to work in here. Yeah. You can stand up at that table and see anything you want. Do you all have, you got the handouts yet? You have the handout? Okay, okay.
What I did was I got 6 pi, 2 pi r. Over 4.
So 5, 6, 7. I should put the answer.
So, oh, it's the total.
It's shaded area.
The area trim is the total, so we're gonna shape there. So shape the total is the length of the cut encompassing the trim. I don't think we're finding the area of this.
67, 3, 6,
So it's 3
67, 3, 6 is number 7 times 10.
3 pi plus
Should be
12.
67, 3, 6, or 67 over 36.
No, it wasn't 670. I'm looking at, did you do number 7 already?
Yeah.
Yeah.
No, 67.
I'm not struggling. Is 67 a prime number?
Huh?
Other than 67.
Well, nothing in this case.
Yeah.
Nothing in the problem goes into 67.
Okay, so
to
we just do
simplify
670.
10
I see.
and 360
Yeah, so,
to
okay.
get 67
I
over
see.
36.
I was ignoring that 10 while you're talking, so I wasn't, I see exactly what
Yeah.
you're saying. Okay, so, yeah, 67, 36 pi. Boom shot.
Me.
We're talking about problem number 7. Squared pi. Oh, there's a cool trick or something like number 5.
What was number 5? Oh, number 5? Isn't it 10 pi?
Yeah, I was on the, I was just doing the basic ones for sector. Yeah, I mean, you see,
Because for perimeter, you take, it's the same as the diameter times pi.
yes.
2 pi r. And then 90 is a quarter block, so we divide by 4.
16 pi divided by 2, 8 pi. That's 40, that's more money.
For 5, you get 10 pi.
For number 9, are we supposed to just find the perimeter?
Let's see. find the perimeter, are you trying to find the perimeter of that
Is,
rectangle?
what is the
The
length
shade
of
is-
the
the
cut
shade
in
area.
Thompson tray?
Yeah,
So the perimeter or the area?
Perimeter.
Okay, that's right.
The
That's
length.
what, I think that's
yeah,
what.
it says what is the length of the cut?
You do Michael?
Yeah, or 2 inches.
Well, what were the units? I did not look at units.
I put the answers to 5, 6, and 7 up here. Why don't you check to see if you agree? Those you got? 5, 6, and 7.
Lauren, did you do number 9?
Yeah,
Where did you do that?
21, what's your
Okay.
Not 25, just 20.
For number 7. Go ahead and keep it. I think that's the answer. You just approximate it. It's
Yeah.
okay. Always write it in the exact one first. You don't have to erase it. That's fine. Oh, I see. You ended up rounding right there, times 5.
Yeah.
So you're really, really close.
It's just not exact.
I'm assuming, I'm assuming.
Well, what I just did is I took this 67 over 360, that comes up to 0.181 something. I wanted to length for
67.
The measure of the angle
36.
is 100 degrees.
Yeah, it just goes on forever. It's better to record it as the fraction.
Okay,
So
so
record it as a fraction, and then that's exact. So 67, 36.
67.
Yes, sir. Well, I think you ended up approximating, which is okay. That's like 75% of the way. Let's just double check. We just do 10,
Where's the pi?
you do 10 times pi.
2 pi r.
Don't you just have to find the 6, this length?
Six,
this length?
6, this length times 36 plus this length.
It equals.
So it'd be 12
Mhm.
plus
Yep,
this
that's
length,
fine.
12, 2.
Yeah,
Did you get that?
and then this length
So
is
Jack,
6
you're right.
pi.
What I'm trying to encourage is to use the exact answer using in its sort of simplified form. So that's why we were simplifying the fraction. Check it out. When you see 90 over 360, do you know what fraction of the circle 90 over 360 is? Yeah, what percentage is 90 out of 360? Well, I'm gonna use a calculator. You see there's 1/4. There's 4 90s in it. So essentially this is, you can change this. Will you write this, I'm not so good at, will you write 1/4? So it's like, you write to write it as 93 66 million, okay, I'm simplify it to 1/4. It's 2 times,
Also,
2 times 1. Change this to 1/4. What's 40 times 1/4?
My major.
Oh, is your calculator a little bit heavy? 40 times 1 divided by 4.
Yeah, for major or if you did
10. That's the same as, when we say that, the same as 40 times that divided by 4, so it's 10. But, so you actually do get 10. This is the exact answer, this is the rounded answer. So the goal is to get exact working, so I'm encouraging you to reduce. And that's a lot of the skill that we're practicing. If you can just generate the approximate answer, that's like nearly 75% right there. That make sense? So it's very much a skill that I want you to set up the formula, just get an approximate 75%. Get the exact by using a little simplification and some of the algebra factoring techniques that I'm showing. That's 100%. Okay. You want to do another one real quick? Alright. So this is just going back to simplifying fractions. 2 times 3 is 6. That's perfect. here's 120 out of 360. I guess the question you have to start asking yourself is, do you see how many times?
Oh, yeah, I got it.
So this should, so would you write this as 1/3 or 3/1? Right,
Are they just asking?
what's 6 times 1/3?
So those
So
It's
you would write
this
this as
one?
2 pi,
plus this.
which is very exact. You approximated it out, right?
So you find this.
This is exact, no rounding. And check it out, we agree, right?
What is the length of the cut?
So you have the skill
Yeah,
of being able to
so
set up the
it's
equation,
this,
plug in what you
it's
know.
the
put it into
perimeter
it.
of the array.
It's awesome. The skill after that you should be practicing is simplifying, like finding common factors.
How would you?
And if you don't see anything, you can play around with the calculator, say, does 3 go into this? Just try to divide it out by 3, does 4 go into it? Divide it out. Okay,
Wait, how did you find?
you're doing good.
How did you find it?
How do you find,
It's not working out well otherwise.
Circumference.
So,
Circumference.
I think there is, you could, check this out.
That arc.
Oh, and then you take it away
Yeah.
from,
You
What is
double
big
it.
4 divided by 2?
yeah, and then you
And
take
then
it
you
away
add
from
12.
the full.
Yeah.
Would that belong in the numerator or the denominator?
So it'd just be 1/2.
You got it. So it makes sense. I kind of agree. I mean, it's definitely one of those. You already divided out the 2 though. You know what I mean? You used it up to erase the 2. And, oops, sorry, this is the exact answer. 27 divided by pi is the exact answer. And this would be the pi. That's good.
You started the sector area section?
Yeah, number 9?
No.
No, it's the sector area.
Oh, no.
I'd like to put up, I'm gonna put up the answers to the 3 sector area problems. These are like the most entry level type questions, right? This is like the most fundamental skill, and then the rest is like problem solving skills, right? You have this tool to find these things. So I wanna make sure that you're good to go with these. If you haven't jotted down the answers, just to have them, that you're ready, please do, because I'm gonna go to the sector area one and jot down those 3 answers. 3 or 4. Oh. Actually, while I have this up here, does anybody have an offering for number 8? What did you get for 8?
15.
You got 15?
Yeah.
Okay. Anybody else? Alright. So we're, maybe by the end of class we can get a few more offerings for that, okay? To the bottom of it.
Yeah, I see what answer number 8.
Yeah.
I got 15.
You got 15?
So I got
Got 15? Let me just double check. Okay.
Because you don't have to do any equation for each.
You don't?
15 is
Hold on,
easy.
TS is the length.
It's fine, but it's
Don't
like,
you have to find the ranges in order to find?
You
because
don't?
you can find that
You can do a proportional or something?
TS is 12 and TS is 80. So then you divide
1.5 pi.
like you find out how much of 360 80 is, and then multiply that by 12, and it gives you 15, I think.
I just divided 12 by 80, then multiply 1.5 times 10.
The length of TS is
Yeah, I did 12 over 80 times 100 equals 15, because you know that SR
And then.
or RS is 100 degrees, so you can find what 1 degree of the circle is by putting 12 over 80,
Oh, I see.
and then multiply that by 100.
It's not 15 pi.
Did you work backwards on the radius?
I
think-
found the radius.
That's cool.
And now I'm working.
That's actually, so if you're interested in how to work backwards, I'm gonna do that really quickly. I think it's a very valuable skill, and it actually gets asked later in the packet where you. So if you're avoiding working backwards to find radius and can solve it otherwise, totally cool. There's gonna be some problems that you're presented with where you are going to. So let's go ahead and address it right now. This is about arc length. So we could say AL is equal to M over 360 times 2 pi r. It says the arc length is 12. It says the central angle is 80. And now we can try to find R. Okay. So 83/60ths, let's reduce that.
21.5 feet.
836 4/18ths.
Oh, for what?
Is that 2 ninths? I think so.
Yeah.
Cool. So this is 2 ninths times 2 times pi times r is equal to 12. So class, go ahead and follow along with me. Bryce, this is important. You will have, I think if you're looking for sort of the higher level, A level techniques, you'll need to know how to work fluently backwards through any equations given to you. So how do we get r alone? Well, 2 ninths times 2 is 4 ninths. Do you agree? Okay. Odin, you with me? You alright with that step? How do we get our alone class? What do you think, Tess?
Divide by 4 ninths pi.
Divide by 4 ninths. Dividing by fraction is the same as multiplying by its. Yeah, what do you mean by reciprocal? So yeah, we'll multiply both sides by 9/4, and what happens is those cancel out. And then you do need to divide by pi. So really, we're dividing by that. Now I've canceled everything out. R is alone. So the question is, what is 9 times 12 divided by 4 pi? What is 9? R is equal to 9 times 12 divided by 4 pi. So class, Bryce, we gotta simplify this guy.
You want me to simplify it?
Sure, I don't know, you were just looking right at me, so it's nice to have a conversation sometimes. Do you see 2 things that we could like reduce, cross out, do something?
So you just multiply 9 times 12?
Totally, so it's 9 times 12.
Give me a second. 111? No.
So close.
112? 108.
108. So this is 108 over 4. Do you know what 108 fourths is?
20.
27.
26.
27? Yeah, 7 times 4 makes an 8. So 27 over pi. So Maddox, I'm not sure, is that what you got? Okay, so this is the radius right here. This is the radius, unless we made a really critical error, but I don't think we did. We crowdsourced this. How could we use the radius then to generate the length of SR? Well, we would plug 27 over pi into the arc length formula. Arc length is equal to 2 pi. R is now 27 over pi. What's the central angle of RS? Okay, 100 over 260. So class, what cancels out right away right here? Or what are some things?
10 over 36.
10 over 36, what does that go to? Well, the zeros definitely.
Yeah.
What else cancels out right away without having to rewrite this line of code that we just put out there? You see something in the numerator and denominator that's the same? We should be pi. There's a pi in the numerator and a pi in the denominator. Whew. Thank the Lord. Okay.
So it'd be 2 times 27.
Which is 54 over 36.
540.
Oh, 5. Oh, it's by 10. Yes. Good eye. So, does this match your answer, Warren? Does this match your answer?
540.
Yes.
540, 36.
Yeah,
Equals 15.
Equals 15. Okay. So Maddox, I guess we verified your radius is good. Maybe it was something after that.
Oh, no, I just didn't get it.
Oh, hadn't gone to this point. Ah, there we go. Okay. Yeah.
You just find what the relationship between 12 and 80 is, and then guess and check till you find a similar relationship between 100 and whatever.
Absolutely, and I think that's what other folks in the class are doing. Did you get 15 that way? Yeah. I went this way because somebody else in class worked backwards, Maddox worked backwards to find R. And this is a really valuable skill.
Okay.
You're gonna see it pop up, but yeah, your technique is awesome. Yes, sir.
I'm not sure how to do number 10. It's similar where you have to, not on this packet, on the sector area one. It's similar where you have to work backward, but I'm struggling on puzzling out how.
Just the algebra.
Yeah.
I guess what could you learn from this one? Like, how is the one that you're doing really that different?
I mean, I guess it uses pi r squared.
So the last step, what are you gonna have to do to undo the square?
Like square root.
I guess that would be the last step that is different for this one. You're gonna end up with r squared equals something.
Yeah.
If you have to divide out a fraction, then you multiply by the reciprocal. If you have to divide by pi, make sure it stays down in the denominator. Does that make sense?
Yeah.
Unless there's a pi over here, then I guess it would cancel out. So it sort of depends. I'm wondering what you can learn from this process. So class, when the bell rings, you can take a quick 5-minute break. Please keep the 5 minutes. Don't come in later after that. We got to keep it sharp, okay?
So this would be
When we come back, we're gonna do an investigation about the equation of a circle. Okay? So know that this assignment is due Monday.
How many feet did you get from?
9, I got 21, we'll see then. Yeah, 7. How did you get 21? I got 7, Lauren.
What's, I got
I got 21.
so, it's 12 plus 3 pi.
You know what? 18.844 divided by, that's it's not even the same price. How the hell?
What?
2 pi r.
Wait, okay, no,
Should
I just,
I
no, stop
say-
ignoring the sign, I did it wrong.
Okay, completely, yeah.
I just have radius first, okay, so we're gonna do this.
Also, why did you round here? You could keep this as 6 pi.
Ignore this, okay, this is the right one, the long math first.
I can't read your hand. It does not say Lewis.
It does not say, it says radius.
Oh.
Lewis.
Morgan, have you done
Answers to number 5, 6, and 7 for the sector area, the most basic ones in exact form.
Number 10 for second.
I did them very quickly. If you think there's an error, please let me know. I'll check it out with you.
Not yet, I'll tell you when I
Okay.
get to it.
5, 6, and 7 on the sector area, just like the 3 most basic ones. Just wondering if you agree. Okay, so there are 2. I'm gonna gotta point something out. Length is different than area, right? Area is like how much space is inside. So the formulas are different. Here's the area formula, the sector area formula. Jack, this represents the whole area, this represents the part. So start with this. And then it's like the other one, you plug in what you know and solve for what you don't know.
Matt, are you allowed to do this since it's pi multiplied by this square?
Yes. Yeah. Totally. Good observation.
Yeah.
36 over 360.
That's
What does that simplify to? So that's really x over 10. I mean,
Well,
this.
this, and that's
And we're not very at all too.
Yeah, look how nice it is now.
Cool.
7 pi.
And then you
for
do-
5. For 5.
and then you just
Oh, wait.
solve it.
Yeah, how would you do the x itself?
You would divide both sides.
Is 1
Or
times.
multiply.
Yeah. 10 times
So
1.
then that's 90 equals 90. We're finding the angle of B based on the area.
Please be back before the bell rings.
Based on the area of the sector.
Keep it swift, keep it swift, keep your class tight. Alex, thank you for participating and letting me use your questions to sort of fuel your class. It's really important. You notice how like it helps kind of get to the bottom of things.
No problem.
I know that sometimes you don't like it. I do know that. I recognize that and I appreciate appreciate your willingness to go along with it. You're super, you have so many great skills and interest in this, and like your writing is so clear and your reasoning is clear, it's a great place to jump off of. And you're just a reasonable person as well.
Thank you.
As opposed to, I try not to always show the unreasonable things, because it just
Yeah.
confuses the class.
So this one, you're not trying to find the area of what the rectangle would be. Because that's what I found. I found 4 feet. This area is like 4-ish feet-ish. I think, I don't know.
Hold on, what is it? She said, so carpenter's making a tray fit between. So this is the tray, that shaded,
Yeah.
the shaded area is the tray, okay.
Yeah.
Using a jigsaw column, yeah. Oh, what is the length of the cut?
What does that mean? Like, what is
Encompassing.
this?
It's like it's basically what's the perimeter of the shaded area. She's gonna have to cut here, 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 and here to make that thing. So, basically you gotta find out this and this and add it to that and that.
Oh, that's so easy. Okay, never mind.
What's looking around a circle? One side is not large. I'm trying to do one against like a circle. It's 1, 2, 3, radius of 5.
Matt, I have a basic question.
Oh yeah, it's break time. What's up?
So if I were to dig a 6 foot high by 3 foot wide by 50 foot long tunnel under 50 feet of Paso Robles formation, would it collapse on me?
Yes.
Well, I mean, it depends on all kinds of things. I think any tunnel, no matter what the substrate is or material you're working with, like you have to.
Exactly.
You have to scaffold it out, otherwise it's eventually it'll, you know what I mean?
And that's not like there has to be scaffolding.
There has to be, otherwise.
Like how often sure it falls?
My question to you is, how long would that take you?
Too long.
We'll find out.
Take you a year, at least, working every day. Where are you gonna put all that dirt? Is my other question. Like that is a mountain of dirt. Like you literally. Hold on, how big? Let's do it. Let's think about it really quick.
It's gonna be 50 50 feet long, probably 6 feet high.
50 by 60.
Well,
Why do you look over there? Like, is it gonna go to lower yard?
it's going to Michael's house.
Why do
Michael's and then he makes a turn.
So that's a lot of dirt, man. I mean,
Also, I don't think
50
it's
by 30 by
50 feet
6.
to Michael's house from upper yard.
yeah, it's a lot more.
A lot more.
So,
Shovels with the
Alright, bro. I'm here to take any final questions you have about this handout. You can write on the front of the handout that I'm available Sunday. I'll have office hours on Sunday, and that this is due on Monday. On Monday, you will have a homework quiz that's going to ask you to be able to accurately calculate the area sectors and arc lengths using these techniques that we explicitly talked about on the board and the examples we did in class. Okay. You will also have to be turning in your problem solving with the GOAT problem and one other that you chose. Okay. What we're going to do next is I'm really excited about. Typically, we don't end up having time or a class that is ready for this at the geometry level. That's not always true, but I think you guys have this. You guys have good instincts and an interesting curiosity, and are good at putting things together. So I think I should show you the equation of a circle, which will speak directly to problem number 3. If you try problem number 3 on the problem solving, and I think on the problem solving handout, and I think when I show you this equation of a circle, we're actually going to derive it. It means we're going to make it together, which is a really cool experience. I've had the pleasure of doing it a couple times before geometry classes, and I think you're going to see that it relates very much to things you are already very comfortable with. All right. Does anybody actually? I mean, without I don't want to play like we don't know anything. Does anybody actually know the equation of a circle? All right. What is it?
X squared plus y squared equals r squared.
So this is the equation of any circle. So the question is, where does it come from? How does it work? Why does it work? So our job today is just to derive that using tools that we already know. Okay? So I'm going to give you a handout. It's got a lot of room for work. It doesn't mean that every single page is going to be filled up with it. I just printed it directly from this resource instead of cutting and like trimming it. So there's just white space that we can fill in. Okay? Doesn't mean that it requires tons of work. It just means there's room to work if we need it. Okay? And actually, a lot of mathematics does take room and space. So this is something that I'm going to do with you. And we probably won't get through with this whole thing today. So in the back of your mind, and we'll see how we end up. I might continue this Monday after the quiz. The quiz specifically will just cover like area of sectors and arc lengths. It won't necessarily cover equations of circles. Okay? I guess unless we get through the whole thing today. It's really going to draw upon previous knowledge. You ready to roll?
Yeah.
So, this is kind of a classic kind of read, and it's investigation based. So it's written in such a way. Oh, did you get one? Test orange. I won't move forward until everybody has it. The goal is to derive this circle equation and be able to graph circles and maybe solve some basic problems. So call this an introduction to the equation of circles, okay? Alright, let's take about 5 minutes.
Just this one.
Yeah, not just this one. The first page. Will you and your elbow partner talk to each other about how you would find the length of this segment? Baby? How would you find the length of this segment? Bryce? Shamsu? Morgan? I want to give everybody a chance just to think for 1 second. How would you find the length of that segment? Raise your hand if you got an answer of how. You got one? Okay, great. You got one? I know you got one. Shamsu, do you got one?
Yes.
Alright. Morgan, why don't you say one way that you would find it?
Well,
I counted the squares and one side's 3 and one side's 4, so therefore it has to be 5.
Okay, so you're using memory in a way.
Yeah.
What theorem does this relate to?
Or like,
Yeah, this is a classic 3, 4, 5 right triangle. Will you jot this down on your paper? That's a very fast way to find out that length. Can we all agree that that length is 5 because of that reasoning?
Yes.
Great.
Matt, what's the distance formula?
I knew that question would come up. I'm just gonna put it right here. This is 3. This is 4, which makes this 5. Again, it comes from this relationship. 3 squared plus 4 squared equals c squared. This equals 25, so c equals 5. You do not have to show this work if you recognize this. I just wanted to support people who might not remember the 3, 4, 5. Very famous. So, and remember, Jack test, any multiple of a 3, 4, 5 is also a right triangle. So 6, 8, 10 is another very famous right triangle. A 9, 12,
15.
got it, is another special right triangle. Okay. This one forces you in and says, don't use that relationship, use the distance formula. So what is the distance formula? The distance formula, I'll give it to us.
Oh, it's a super long one. Oh, I don't.
I just want you to recognize that all this is asking you to do is to subtract 2 numbers from each other twice, square it, and then add them together.
Matt, you forgot the square of those.
I need to use pencil. Where's my pencil? Great. So let's recall how we accurately use this formula. I guess I am using this pencil. We can label these x1. X1, Y1, X2, Y2, and it just says subtract the x values. In my mind, I like to just do this and connect the 3 and the 9. So I take 3 minus 9, and in my mind, I do this y, take away that y. I draw those arrows just to make sure I'm picking the right inputs. Great. You guys got it from here.
It's 10.
You should get 10. Make sure, I want to pause, make sure everybody gets to 10. Just a little side note, when you square any number, you should get a positive. So if you square this and you get a negative, then you didn't close the parentheses on your calculation. So I guess the next step looks like parentheses negative 6 squared, which is positive 36, and parentheses negative 8 squared, which is positive 64. Okay. So, looking at the formula that was given, if you have no experience with the equation of a circle, don't worry, here it is. Can you see elements of that in the distance formula?
Y, X, squares.
Can you see elements of that in the Pythagorean theorem or the Moo theorem?
Oh.
Totally, can't you?
A
remember-
plus B equals C, it's X, Y, and R.
So there's some similarities, and I don't know if you recall, in the first month, probably the first couple weeks, we changed this relationship into the distance formula. We actually derived it. We were like, oh yeah, they're basically saying the same thing in different ways. So I just want to keep that in mind as we move towards this. Any questions about the distance formula? Cool. Alright, this is where you get to play for a second.
Jesus,
All right. So, can you read the intro for this big blank piece of paper here?
If we graph all of the points whose distance from the origin is equal to 5, what shape will be formed?
We say it one more time, real loud.
If we graph all of the points whose distance from the origin is equal to 5, what shape will be formed?
Graph all points whose distance from the origin is equal to 5. Okay, so let me give, what shape will we get? No, we'll get a circle, right? Anna, can you name one point that we know is gonna be on the circle that I could plot here?
0,
Boom, 0, 5 right here.
5, 0.
5, 0. I'll just go -5, 0, and 0, -5. We know that those 4 points are definitely gonna be a distance of 5 from the origin, right? Can you find 4 more? You and your elbow partner find 4 more that you know, and these are gonna be whole number points. I'll just find 4 more whole number points. Like, where is the distance of 5? Where is the distance of 5? We know it's like somewhere around here. Can you and your elbow partner look for, I don't know, I'm asking for 4, but if you get 1, you'll be able to generate the other 3. Alright? And there's a reason why we did that problem on the first page. Just a little hint. There's a reason why we did that problem on the first page.
Can I generate 8?
You can, generate as many as you can.
I generated all of them.
Okay, let's
Hey, no
see.
compass, no compass. Oh, okay, so you can use a compass, but you gotta share that compass because, alright,
Oh,
if you think that the only way to figure this out is through compass, what was that famous right triangle that we just talked about on the first page? The 3, 4, 5, the 3, 4, 5, the 3, 4, 5. How does that relate to points on the circle then?
because you can go from
Place a point at 3.
0,
place a point
0,
at 0.
and just go down 3 and 4.
So I can go down 3 and over 4, and this should have a distance of 5 right here,
and
shouldn't it?
then if you go down 4 and over 3,
Yeah, 4 and over 3.
or
Oh,
the other
Yeah,
direction.
so I can go this way or this way.
Yeah.
Can you see, I mean, it's totally allowed to draw this on paper, I shouldn't be scared of that. I was gonna go to the board. This is a 3, this is a 4, so this must be 5. Go ahead and plot all 8 points we get from the permutations of 3 and 4, being both negative, positive, and switching. So we should get -3, +4. -4, +3.
And this would apply for any circle that is a multiple of this.
Yeah. Well, how would
Like
these
if
points
the
would also
radius
be?
was 10 or 15.
Oh, that's a good question. Holy smokes! Would those, when we did similarity, when we enlarged by a common scale factor, didn't all the points enlarge at the same? Yeah.
Yeah, so
Yeah.
it would be.
Yeah. So 6 and 8 would be the points for a radius of 10, right? Yes. Ooh, good observation. Okay, this is where it is really fun to have a compass because then you're gonna hit all of them real nice and smooth like. Otherwise, just do your best to draw a smooth curve, smooth circle. I have one set of 5 if anybody wants to borrow. And you can pass it around. But know that we found those without a compass. Just using the idea on the first page. Okay, so I think we need to make sure that we understand how we got those points. Katie, how did we know that this point right here, -3, -4 was going to be on that circle? What was the clue?
On the page before.
What about the page?
So where they use Pythagorean theorem, find that if it's 3, 4, 5 triangles.
Exactly. 3 and the 4 generate that 5 every single time. Yes?
There was a GIF you showed us that was this, but it was moving. It would like
Oh,
spin.
yeah, you can see that the triangles kind of grow and shrink and change. That was for trig, right?
Probably.
Well, so, I'm gonna zoom out here a little bit. We were able to get 8 points. Well, 8 plus the 4 on the axis, so we were able to get 12 points. I guess the goal is how would we generate any other point? Like, this isn't a whole number. How could we get it? This isn't a whole number. How can we get it? These are points on there. So I'm gonna lead you through a little bit of, I'm gonna do a little pattern-based reasoning with you, and I'd like you to copy down what it is I'm about to write. I'm gonna build a table. So make a T-chart. On the left, we're gonna put the point on the circle. For example, we'll do like -3, -4. And on the right, we'll do the distance to center, which is 0, 0. Okay? We'll do this a few times, and let me know if you start to see a pattern. So to find the distance between any 2 points, we can use the distance formula, right? So I'm going to write this as, try to follow along. I'm going to do -3 take away 0. I'm going to do this take away this, square it, plus -4 take away 0 and square it. And what do we know this is going to simplify to? Should be 5, right? Yeah.
So if it's a
Well,
point
hold
on
on.
the circle,
Well,
from this, like from the center, it's gonna equal the radius.
hold on, say that again. Let me do a couple more here just so we can sort of see what's going on. I'm going to do the same thing but with 5, 0 right here, okay? So the distance formula say we do this, take away that, 5, take away 0 squared, those are the x's. Now we want to do the same thing for the y's, 0 take away 0.
It's gonna equal 5 again, right?
They all equal 5.
Yeah, no, if it's a point on the circle, like compared to the
They're all
origin or the center, it's gonna equal the radius every time.
Alright, let's do it with 4 and 3 just one more time and just see that there's something steady going on here. So we'll do 4 take away 0, those are the x's, square them, add it to the difference of the y's. That's 4 squared plus 3 squared. Does that equal 25 as well? And then the square root of 25 is also 5.
So would x and y for the equation of the circle be the, like, x be the same as the x-axis for the center?
I mean, yeah, but when it's on, yeah, when it's centered, do you see where the center of the circle shows up in these calculations?
Yeah.
They show up here, 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 and here, right? That's where the center shows up. Where do the endpoint values show up? Here, 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 and here, right? Keep that in mind, okay? We're gonna draw one more circle, okay? Things are doing great. Are you ready for this?
Mm-hmm.
Alright. Katie, will you take the lead again? What's it say right here, for example, 2?
Let's look at another circle, one whose center is not at the origin. Shown below is a circle with the center 2, 3, and radius 5.
Okay. Well, can you find some points on this thing? It's not centered around the origin anymore, right? So let's crowdsource. Does anybody have a
7,
definite?
3.
Okay, 7, 3. Thank you, Morgan.
-3, -3.
-3, -3. Thank you, Katie.
3, 8.
How about 2, 8?
2.
Yep. check this one out. 5, 7. Do you agree?
Wow.
5, negative 1.
5, negative, yeah.
Negative 1, negative 1.
Negative 1, negative 1. Now, if you still got that compass set to 5, you can sort of sweep this out if you had to as well. So what else?
Negative 2, 2.
Negative 2, 2, negative 2, that's right here.
2, negative 2.
2, negative 2.
Wait, what's next?
It doesn't look,
Oh,
oh,
no.
sorry, I'm miscounting. Yes, 2, negative 2. Thank you, Bryce.
6, 0.
6, 0. Oh, yeah. With certain, I mean, So-
I guess it would be,
so then we can go over here.
or no, negative 1, 7.
Negative 1, this guy. And then should be this one. For any
Negative
That's
1,
6,
5.
6.
Negative 2. Hold on.
Wait, where did I
6, 6, is it this one?
Yeah.
Oh. So we got those 12 critical points. Are you just seeing, I mean, I guess you could point these out because they seem to cross at a whole number. What's the connection to the previous work we did though? Circle? Yeah, yeah. And the same, width's the same radius as well, right?
So it's got.
It has a distance of 5, right? So I'm just gonna do it here. So this has a distance of 5. So should we be able to make a right triangle with sides of 3 and 4 then?
Yeah.
That helps justify it. We also could do it, you know, side of 4 and another side of 3. We get all of these. Okay. So I guess we're still begging the question, how do we find some of the others that are not whole numbers? And we know that this is the relationship. We're gonna build one more table together, class, really quickly and make some observations, okay? Oh, by the way, the center of this is at 2, 3.
Matt, I think this is how windmills are made.
Okay.
If you put right triangles in a circle.
Oh, if you put right. Oh, you're saying like the fan blades? Yeah.
Yeah.
I think Bryce is gonna need several of those for his tunnel.
Keep the
Generate power, and circulation is something that you gotta have in tunnels. If you don't have circulation,
Okay, why do you want to go to Michael's house?
point on circle
I don't
Still
know.
need to put that diversity.
and distance to
Too
center.
much time.
Come on. We're gonna do the same technique. Again, I'm trying to speak to your pattern-based reasoning here to generate the meaning of, or to generate some meaning of this equation, okay? What's the point on the circle? Well, there's lots of them. Let's start with 5, 7 is going to be calling my name. The center in this case is 2, 3. So we're going to do the distance formula right here using this point and that point, okay? I connect these in my mind. Hopefully you're saying, oh, I just subtract the x's. So test, I'm just going to do 5, take away 2.
2 take away 5.
You want to go that way?
Does it matter?
If you square the result, does it matter?
No.
So take your pick.
Okay.
So I'll do 5 take away 2 squared plus 7 take away 3 squared. And that should get us a distance of what? 3 squared plus 4 squared. 3 squared plus 4 squared.
4 square.
Are you just naming random maps now? You're naming random maps. Okay. 3 squared plus 4 squared. That's a.
Remember that game though?
Yeah.
4 squared?
Oh, now you're naming. I think of it as an app now. That's not what it's like.
Yeah, there's 4 squares.
Whoa.
Dude, 3 squared plus 4 squared.
16 plus 9.
Which is
5. I mean,
after
well,
square root.
Yeah,
After square root. I agree. I know how to jump to conclusions. Well done. Okay. Let's. Odin, since we have such a great thing going on, pick another point for us to do.
2 negative 2. Or should we do one of the other ones then? So we don't-
It's up to you, man.
Okay, I think we should just, 2,
2, 8. So let's go ahead, we'll do 2 take away 2, oh, I like that one, 2 take away 2, that's subtracting these x values. And we do 8 take away 3. So 0 squared plus 5 squared.
5.
25 square root of 25 is 5. It's all working out, class. We're gonna do one more. Yeah.
What if we build a 4-square court in?
Hold on. I like the one where it's the octagon and we put all the little kids in there and they fight it out. What's that called?
I like that game too.
It's cool.
It's really
Build one in geometry.
But I think
That could be your senior project.
Wait, Matt, can
That should be your
can
senior
that be
project.
our final instead of a test?
Oh, yeah.
It should be your senior project though. Just bookmark that thing.
these.
No, we've already talked about this. That we're doing
Okay,
it.
we got it.
Yeah,
That's
that's
what I was
But
talking
Matt,
about. The juniors like, not if you don't do it first.
They're not.
Are you kidding me?
Anna, we need one more point.
Tables.
We got a good thing going on here. I like this report. Once she's one more point, we'll do it one more time.
Yeah, you can literally just.
Any point, we're gonna check. We're gonna just make sure it works out.
Negative 3, 3.
That's me. I was asking you for another point for us to check.
Family school.
Anyone that's
Just
labeled.
steal theirs.
Oh,
The class before mine put it.
7, 3.
7,3.
The juniors.
Okay. Connect the x's. What x's are we subtracting for this particular point? Class, you tell me. 2 minus 7. That's negative 5 squared. And then, the other one would be 3 minus 3. So we get 5 yet again, because negative 5 squared is 25 plus 0 squared is 25, square root of 25 is 5. Okay. Class, can you see where the center of the circle is represented in this formula?
Yeah.
You can see the center represented here.
And it's flipped.
Oh, sorry. You can see the center represented here and here, right? The 2's and the 3's are represented there. Cool. And you can see where the endpoint or the point on the circle is represented. You can see those 5, 2, and then 7, right? Okay. This formula is only sort of, this has, what am I trying to say here? Maybe before I say something, I think we need to do something, okay? Those, remember the 2 prompts that Katie gave us to do these 2 circles, right? What do we know about those circles? Are they the same or are they different?
Oh no.
I guess maybe the geometric, are they congruent? Maybe.
Yes.
Okay. Remember when we moved congruent figures around? Remember that whole thing? Stuff like that? So can we say that this circle, can we write a translation rule? All points are translated where, this is example 1 on the first page, where it was centered at the origin, those would x, y. Where did all of these move to? So again, let me just, I'm gonna go back to here. Here's the original, centered at 0, 0, radius of 5.
2, 3.
So how would we write that using a translation rules? Is it x plus 2 or x minus 2?
X plus 2.
Because it moves to the right, and then it moved up 3. Okay. So that's if we go from example 1 to example 2. What if we went the other way? What if we went from example 2 to example 1? What would that mean?
Instead of adding 2,
So I'm running out of room here, but I want to write it down. So it really matters the direction in which we, or the order in which we do it. So you said we would do x minus 2, y minus 3, right? I wrote it down at the bottom, kind of crammed it in, there's a lot of room on your paper. I wanna make this really clear that the direction matters in how we write this. So if we go from example 1 to example 2, we're adding 2 and 3. If we go from the transform figure back to the original, then we're subtracting 2. And subtracting 3. Alright. So, how much time do we have? Okay. Before we move forward, I'm gonna quickly tie this into the equation for a circle, and then I'm just gonna give us a chance to play with it, okay? But before I do that, I want to see if there's any questions about what we've done so far. Okay. Since I'm running out of room on the paper and I don't necessarily want to, I need to refer to this, I'm going to maybe erase the board over here and just write what the final equation of a circle is and how it behaves, and then maybe help let you make some connections, okay? So, where is our wiper? Oh, here it is. So, you'll need to find some room on your paper for this. It's not going to take up much at all, but this is sort of the punchline, okay? Jack, you ready for this? The equation of a circle centered at the origin
I know.
This is a true statement. This is when it's centered at the origin. And we saw that because you could plug in the 3, the 4, and get out the 5, right? We saw that for the very first stage. Or the very first example, I should say. Question. I don't see a square, just to relate over here, I don't see a square over here. But there is one here. Let me go back to the one centered. Say that again? Oren, did you hear what your neighbor was saying?
Yeah,
What did she say?
the square root.
Okay, what about the square root? You and Jack gotta be here, this is the deep thinking part. So we noticed that in the equation that I just gave you, has a square on the R. If I square this side, what has to happen up to the other side?
The square root is y.
The square root goes away, right? So you have something squared plus something squared equals R squared.
Yeah.
You see that connection to the equation? Okay, great. Okay. This is the second part to the punchline. The equation of a circle with center HK. That means it doesn't have to be 0, 0. It could be a 2, 3. Is this right here? And I think you'll see why. Is x minus h squared plus y minus k squared equals r squared.
Yes. Because in the distance formula we're using, the center is always the second value.
The second, yeah, in those
Yeah.
parentheses, right? So just to be clear, h and k, in this case would be 2, 3. Do you see how 2 and 3 show up right here in the second value in the parentheses? Katie, see, Max,
Yeah.
see? HK. Where
You switched them.
This one got switched. Remember? Well, no, it's still HK, but the way Shamsu just had us subtract the other, which is totally fine. It's totally fine. They can, as long as you're consistent. What this means is you can generate any point on a circle now using this formula. Just like when you learned you can generate any point on a linear equation by plugging in a value of, say, x, and for your y-intercept, and you'd be like, oh, the y value is 13, the x value is 2. This is a point on that straight line. You can do the same thing here. You find its center. You can generate other values. This is totally an introduction, and thank you. That took about 25 minutes. Their class, you could spend a long time studying the equation of a circle. We're going to play around with it a little bit more today, maybe do a few practice problems. We'll continue practicing with it and maybe do a Desmos activity on Monday. Monday, your quiz is not going to cover equations of circles. We'll just cover sector areas and arc lengths. That'll take 15 minutes. Then we'll do a little bit more equations of circles, okay? So let's go ahead and apply a couple together. So how does this work when we say the rubber hits the road? Okay, great, I have this formula. What do I do now? I'm gonna have to do this math stuff. Well, I've had a chance to talk to some people in this class already. Number 3 on that problem solving handout, the one with the, I don't know, did you look at the number 3 on the problem solving handout from Monday? It asks, it actually, the 2 circles. This will speak to that if you're interested in doing it. You have all the tools you need, and it's actually, it's not a super tough problem once you have the equation. Write an equation for a circle whose center is at 9, 0 and has a radius of 7.
So it would start off as
Alright, everybody, I want you to pause for 1 second. And I want you to write this form down right here. X minus h squared plus y minus k squared equals r squared. Great. If this is the general form of the equation and you're asked to write an equation, then that's what you need to use. Use the form. Now plug in what you know. Raise your hand if you can tell me the h and the k value is center. The center.
Is it always HK?
Some textbooks might call it AB. It just matters it's x minus whatever that is. And this is the x variable of the center. And this is y minus the y variable of the center. Alright, Morgan, what do you say h is?
H is 9, K is 0.
So this would be h, k. So x minus 9.
But I have a question about X and Y.
And, hold on, what was it? Y minus 0? Okay. Can somebody tell me what goes in for r?
7 squared.
Got it, 7 squared. So, let's get to something. Is the radius 7 or is the radius 49?
7.
It's 7. Just know that sometimes you might see it written like this, and you just have to pause and be like, okay, it's not squared. I need to take the square root of it to get it. That's just a little foreshadowing. The radius is 7. Great. You would be welcome to write this as just y squared instead of y minus 0 squared, but no problem. Yes, Maureen?
For X and Y, can they be any point on a circle?
Yeah,
Okay.
yeah. So most of these questions just ask you to just make sure you understand what the x value and the y value of a point on the circle is, and what h and k represent, which is the center. So these are mostly fundamentally introductory classes or questions. Will you in your other partner try to write an equation for this circle right here? Again, use this format. And I want to come around in just a second and check to see that you were able to find the center and the radius, okay? Will you write the equation for this circle right here by plugging in what you know? No solving necessary. Ooh. I mean, you're just showing how it works out. Right, x plus 2. Y minus 4.
I thought you wanted like the actual points because you have points.
Hold on. Just the equation.
Okay.
Just the equation that will generate all points. Looks great. Boom. So, your graphing calculator, I don't know if I can actually do this, but I would be remiss. You know what remiss means? It's a cool word, I think. If I didn't show you that you could plug this into like Desmos or something?
Just the regular, just the
So,
blanket.
is it x, what was the equation y'all just
X
wrote?
minus 2 squared.
It's X plus 2,
It's plus 2.
because it's a double negative.
Is it shifted right or left?
Shifted left.
Okay, so shifted left should be x plus 2. And this is why having Desmos at your disposal is really nice, because you'll be able to see plus x.
Y.
Oh,
Y minus 4.
mine.
And then equals 2 squared.
Equals, so 2 squared, I'm gonna put 4.
Yep, that's it.
Check it out.
Wait,
It's
what?
And then look at every single point.
That's a lot of points.
This is how really cool things are figured out. So, alright, looking at this assignment. This is actually the first time I've used this handout. I've taught it from other books. So I haven't had a chance to really kind of go through every single piece of the homework. I think most of it is pretty elementary, like plugging in your H and K, or using distance formula. Yeah, there you go. So for this one, since I haven't done this assignment before, let's write that it's going to be due the following Thursday. Yeah, it's going to be due the following Thursday. Let's do a few more practice problems. Did I tell you that we were going to have a test next Thursday on circles? Remember I said we would do arc length, sector area, and equations of circles? Just so you know. So look, we're going to do circles today. We're going to do quiz Monday. Play with more of the equations of circles on Monday as well. You'll get a review on Wednesday. Or I can hand it out. I'll probably hand out a review earlier than that, so you have it at your disposal if you want to take more time. And then, so then Wednesday will be a review workday, and then Thursday you'll have an exam on circles. Let's do a few more of these, actually. Let's do a few more of these. Class, for number 5, what is the radius and center?
9 and am I allowed to just say?
Hold on a second, let me get writing position. Yeah, I want to get to the bottom of this. What is the center?
Negative 12, 4.
Yeah, because
Because it's a
the
double.
formula is x minus h. You'd have to put in a negative 12 to get a positive 12. So you get negative 12, comma,
4.
positive 4. And the radius, is it 81 or is it the square root of 81? And you would want to rewrite that as 9 squared. Alright, Petra, that's a cool name. Given the equation x minus 15 squared, and identifies the graph of the circle whose center is negative 15, 4. Has Petra made a mistake?
Is that a fish?
We'll put a pin in that one. Why, Odin?
Because it would be 15 negative 4 because you're actually taking away the 15 correctly. Everything's going as planned, and then y plus 4 would be y minus 1.
So you're saying the center should be at, what did you say the center should be at?
The
Positive
center
15?
should be 15 comma negative 4.
Negative 4. So not taking into account that it's x minus h, so that's a straight up 15, and it's y minus 4, so we need to plug in or y minus k, so we'd have to plug in a negative 4 to make that work. Remember what the general formula is, and use that as your guide. So radius is okay? Radius is 10?
Wait.
Yeah, 10 squared is 100, right? Awesome. Again, if you have any questions, let me know. I'll see you Sunday if you want some more help.
Yeah, I'm okay.
What?
Can I buy it?
Yes, I realize that, and
Definitely suffocate.
I'm still telling you that digging a
Radon,
hole up your
carbon
varsity hill is
monoxide,
not
stagnant air, bad.
the smartest thing you've ever had.
Thank you, Matt, that's actually really fun.
I'm glad you thought so. I'm glad you guys are ready for this. Some classes I can't like get to like, I can't get to some of like, the good stuff takes time. You can't just like play your way through everything. Like you gotta think. So I'm really happy for you and for me as a teacher too, because I mean it's what you deserve. That's why you're paying big money to come to school. Just is to dig tunnels and to learn a little math.
To learn how to make a circle.
See you, man.
Yeah.